Okay, good day class. Alright, so last video, the first video, we have discussed the basic concept about vectors. Alright, and we have discussed 6 type of vectors. Like the first one, zero vector, negative vector, equivalent vector, parallel vector, unit vector, and one more is parallel vector is zero vector. Alright. So we have discussed the basic 6 type of vector. Alright. Okay. So today we will see vectors in 2 dimensions and 3 dimensions. Alright. So vectors in 2 dimensions, I think it's no problem. It's very familiar to you. You have learned this one in Form 5. Okay. So vectors can exist in many directions. So 2-dimensional vectors, or we call it coplanar vectors, are described by the order pairs. Order pairs means 2 elements in one bracket of the Cartesian coordinates xy and drawn on the xy plane. Just 2 dimension xy plane like this. Okay, so now we are going to the 3-dimensional vectors. Alright, so this is the diagram of the 3-dimensional vectors. So the last video I have explained to you a bit how we get this diagram, right? At first is xy axis like this. The last video, okay, this one, remember? 2-dimensional is like this, xy. So we rotate this one. So you see, rotate clockwise. We rotate clockwise until we get something like this. Then this is the third axis z, which is perpendicular to the plane, the horizontal plane. Alright, so normally we will draw it in this. It is like this lah. But normally when we want to solve equation, we will draw in this way. The horizontal line will become your y-axis. This is your x-axis, and the vertical one will be your z-axis. Alright, it's 3 dimension. Okay, so the 3-dimensional vectors, or we call it space vectors, are described by the ordered triples. So for 2 dimension, it's ordered pairs, so 2 elements. So for 3-dimensional, we call it ordered triples of Cartesian coordinate x, y, and z. Alright, and drawn on the xyz plane. Okay, so the power of vector method is best appreciated when they are used to do geometry in 3-dimensional, or to solve 3-dimensional geometry question. Okay, so this requires setting up axis in 3 directions as shown in the diagram above. This one. Okay, the usual convention is to take x-axis and y-axis in the horizontal plane, or imagine it's on the floor or on the table, and to add z-axis pointed vertically upwards. Alright, so you must have the concept. This z-axis, okay, is perpendicular to the whole horizontal planes. Alright, then see, these axes are said to be right-handed. So if the outstretched index finger on your right hand, alright, right hand, okay, so your index finger point to the like this, point to the okay, like this, point to the x direction, and you bended your middle finger to point to the y, middle finger. So this is x, middle finger is y, xy. Okay, xy. So index is x, this is y. Okay, then your thumb will be straight up. Alright, so your thumb will be the z direction. Okay, so number 4, the position of a point is given by its order triple of the Cartesian coordinate x, y, and z. Okay, so almost everything that you know about coordinates in 2 dimensions carries over into 3 dimensions in an obvious way. Means that anything you have done, the vector in 2 dimensions actually can bring to the 3 dimension. Alright, but you need to notice a few differences. So there are a few differences between 2 dimensions and 3 dimensions. Okay, the first difference is the axis can be taken in pairs to define the coordinates plane. So for example, the x-axis and the y-axis define the horizontal plane, and we call it xy plane. All right, and all the points in the plane has z coordinate 0, means it's on the horizontal. All right, therefore, the equation of the plane is z equals 0. So we know that when you have lines in 2 dimensions, when you have lines, curve, all this, they have equation, right? So plane also have equation. So on the xy plane, the horizontal one, all right, so all the x coordinate 0, therefore this plane we call it z equals 0. So similarly to xz plane and the yz plane, all right, which has the equation y equals 0 and x equals 0. So they are both vertical planes. All right, so maybe we will see at this box.